name is Lars Rönnbäck. I'm currently working at a small consultant company in Stockholm, Sweden, where we're working with data warehousing and analytics. And it's something I've been doing for the last 20 years now. Apart from that, I also do part-time research at Stockholm University in the field of information modeling. And in particular, something called transitional modeling right now, which is something that I will be touching upon here. Some noise in the background. Someone should mute their microphone, perhaps. So the title today is It is High Time for Bottom Up. And I want this to be sort of a contrast towards somewhat of a movement we've seen lately anyway with top-down methodologies. And I want to start to look at some of the modeling techniques that we have today. And the first one is ensemble modeling. It's sort of the umbrella for data vault, anchor modeling, and focal. And what do we do when we do ensemble modeling at a client? Well, we come to a business. Business is the top thing there, works with something which is not the business. We try to deduce the core business concepts from this business, sort of the stuff that the business is working with, in order to create a specific model that fits this business. And finally, we try to get data into this model by sort of conforming whatever is out there in the business so it fits into the model. And I would like to say that the key word when you're working with ensemble modeling is to be inquisitive. We want to know what the business is doing. We want to know what it's talking about, things like that. So it's the model that results from this is quite specific to this particular business. And if you look at the constructs that you find in such a model, they have very recognizable names like customer, invoice, payment. And of course, that makes it quite easy to conform information to put into this, because it's quite straightforward what the stuff is that the business is working with. And it's probably not too far off from what the different systems that you will be integrating are also working with. Then I'm sure you all heard of industry models. They are a little bit different. They come with some particular modeling technique to begin with. And the difference here is that instead of having a very specific model for a business, you get a model that is more generic. So they have sort of figured out what businesses like your business are doing in general, and they try to make a generic model that fits all types of businesses like yours. And the key word then is no longer to be inquisitive. The key word here is to be authoritative. And so they basically come to you and tell you that they know what type of model you need. And that could perhaps be comforting for some, but it surely can make those conformed loading a little bit more difficult, because now in the generic model, you may have some more generic terminology. So you no longer talk about a customer, you talk about a party instead, and instruments, transactions, stuff like that. Still though, you probably can conform information to fit into this model from whatever systems you have in your business, as long as you get some way to, well, you have to have some sort of rules for how you translate and put stuff into the different entities that you have in this generic model. Taking it one step further, and this is actually quite a hot field right now, which is the ontology field. I'm sure those of you who have been following like the graph databases and their march forward have seen that they are also very interested in these ontologies. And what are they? Well, they are sort of like industry models as well. The difference being that they are not sold by anyone to you, really. These are more scientific artifacts. So that's good, of course, because being scientific means there's also some sort of rigor behind it. So when you have an upper ontology, you get an even more abstract model than the generic model, because upper ontologies, they have to sort of encompass everything. Maybe not just your business, but everything that goes on in the entire universe. So these models tend to become quite abstract. And if you look at it, the entities that you will find in an upper ontology model usually have names that are really unfamiliar to you, because they need to be so generic that you can fit almost anything in there. So they talk about stuff like persistent, presentials, coincidences, just to take a few as an example. And of course, now if you're going to conform information to put into this model, the rule work that you have to have in place in order to just figure out what your stuff is that fits into this will become quite substantial. So comparing these three different types of models, we can see that, I'd say anyway, that most of us that are at this conference have been moving in the direction of this green arrow, whereas we're not moving in the direction of the red one. And why is that? Why are we moving towards the left here rather than to the right? Why aren't we using upper ontologies in our relational modeling? Why is ensemble modeling techniques so popular right now? Well, I think the answer is quite simple, because if you look at it, once you have something in place, a data warehouse, for example, you need to maintain this. And that means that there are daily operations. There are people actually working with your data warehouse every day. And looking at ensemble models, they are built for flexibility. So whenever something changes in the surrounding, you can adapt quite quickly, even if it means that you actually have to adapt in all of those three encircled areas. You have to evolve your business concepts, you have to evolve the model, you have to evolve the ETL flows. But still, it's built for adaptation, which makes it rather simple and quite flexible to do this. And also, whatever you do in the model, it will be your model and your changes. If you look at the industry models, well, the industry model is sort of what it is, so you can't really do anything with that, but you can probably adapt the generic model. The difference is that once you do that, you're sort of on your own, because if you run into trouble and the vendor comes and looks at the columns you have added that were not there from the beginning, they're going to tell you that, well, you voided the warranty, and they're not going to help you at all. So it's harder and a bit more inflexible to work with these industry models. And finally, of course, we have the upper ontologies. And here, well, how would you actually adapt this? Well, you can't really work with the ontology. You can't really work with the abstract model either, because those are more or less written in stone. So the only thing you can do here is sort of become a scientist, find a good chisel, and chisel in the word customer into that ontology. So this makes it really hard to work with from a flexibility perspective. And I think these are the reasons why we've moved towards the left rather than to the right. Now, if we also think about this, when we move to the left, we're going sort of more and more towards a bottom-up approach. whereas the thing on the farthest to the right here, the upper ontology, is very much top-down. So then you can ask yourself, is this as far down we can go? How low can we go? Is this the epiphany of bottom-up? Well, no, it's actually not. And this is where my research have been focusing lately around transitional modeling. And a conclusion we can draw from this is that the closer to the objective and universal top we get, the farther away you actually get from the subjective and local reality of the business we get. So I think that's a reason, like I said, to move sort of more towards bottom up than top down thinking. All right. So what have I been doing in transitional modeling? Well, I've been trying to look at things from an even or quite far away even from ensemble modeling to be very, very close to the bottom. And if you look at this example here, you see that there's an orange in the middle. And there's actually a process that goes on when we sort of define what this orange is. And the first step is actually to identify this thing that is in front of us. And we do that by actually seeing that this is something that is separate from everything else. We decide that this is worthwhile to be given an identity of its own. The second step is qualification. That is the step in which we determine that there are some properties that this thing that we just identified has got. Like we can say that it has a color, it has a shape, it has a size, and those are properties that this thing has got. The third step is evaluation. Once we know the properties, we can also assign values to each of these properties. Like when we know that it has a shape, we can say that the shape is round. When we know it has a size, we can say that it sort of fits in the hand. It has a taste, it's sweet, etc. And of course, this evaluation, it's sort of subjective and imprecise. It's hard to actually it's impossible actually to get perfectly precise measurements of anything. And finally, actually, we get to the step where we do classification. Because that requires us to have seen many oranges and oranges before. And if we have done that, we notice from knowing that, seeing the shape, the smell, tasting it, we can actually recognize this as being something that we've seen before. And we call this thing orange. So the classification comes quite far down this process. And I've been trying to figure out then, what do we actually have to agree upon in order to have some sort of fruitful discussion. And those are the things on the left side, the two first things. We need to agree upon the identities of things. We also need to agree upon what properties things have. And the further I go to the right, the more subjective the stuff gets. So the last two, what values those properties have and what class this thing belongs to, I would say can be entirely subjective. Maybe someone would say that oranges taste sour rather than sweet. So in transitional modeling that I've been working with, we're actually not starting with classes. And this is quite a big step from traditional modeling techniques, where classes is sort of the fundamental building block that you have. Instead, we start with these properties. Properties are the fundamental building blocks of transitional modeling. And classification and classes in transitional modeling, they are subjective and they are ephemeral also. They might not live forever either. You can change your mind about what class something belongs to. Or something can belong to multiple classes, etc., etc. So we have just a bunch of properties in transitional modeling, and when we look at it, like I said, in order to do classification, we need to have seen several things. So once you've seen many things, you can actually group these and say that some of these properties that I have in my data, they are shared by different things. So in this case, if you look in the middle, you can say that there are 12,000 things in my data that has size and color. 9,000 have size, color, taste, shape, and smell, etc. So this is sort of like those isopleth maps where you can see the height differences using lines. And of course, once you've seen this and know the numbers and seen stuff like that, then you start to figure out what would my model look like from a classification perspective. And perhaps you want to call one of those things food, another fruit, and product. So these are the three different classes that I figured out that these things would capture these things quite well. But of course, once you have that, oh, sorry, not yet. And a neat thing here is that you can see when you're working with properties like color, which is in the middle there, it's a property that is actually shared by both food, fruit, and product. So all of these things have color. And if you were to build a database that works at its core with transitional modeling, you could basically search for, give me everything that is light green, and then it would return to you stuff that is food, fruits, products, whatever, because color is one property that is shared by many things and different classes. Quite different from how yep, quite different from how we would do it in a relational database. And of course, once you've created your model and feel quite satisfied with it, someone's of course going to come along and rain on your parade and say that, well, I think grocery is a better name than product, and food, I'm not so sure about that, because smell, color, taste, and shape, well, something else could actually fit in there. And I'd say that everyone is, of course, entitled to have their own opinion. So in transitional modeling, you can actually capture these differences of opinion. And you need to find and strike sort of a balance there between how many differences of opinion would you like to capture versus sort of having some sort of consensus also about the model so it's still useful. I think the way we do it now, where we have just one classification and it's the only one, certainly has to be quite limiting. Whereas if everyone were to have their own unique personal model, that wouldn't be quite useful either. So somewhere in between is probably a good balance. And this discussion about what comes first, properties or classes, is not a new one. This is quite old. It was even the old Greeks like Aristotle and Plato had long debates about this. So if properties now are the base that we would like to start with, how could you then tell an apple from an orange? This is something I posted on LinkedIn, a question a while ago. I don't know if someone saw it, but it got a lot of answers. And I promised to bring it up here. So what I'm going to say is that fruit, like the class fruit, I'm going to say that that is just a shorthand for a number of properties. So we're still in this objective part of reality now. I'm just going to say that it's a number of properties. If anything has all of these properties, not values, properties, I'm going to call this the class fruit. And of course, if I add another property here called the name of the fruit, and the name of the fruit would then be apple or orange. Well, the way I would actually determine if it is an apple or an orange, I can't do that by just looking at the properties. The only way I can tell if it is an apple or an orange is by actually sampling or getting the values for some of these properties. So once I know how it smells, how it tastes, and which color it has, then I can deduce the name of the fruit. So the difference between a classification is that the class is just a shorthand for a number of properties, whereas a type is something that also needs you to determine the values of some of those properties. Then you can deduce the type of fruit as well. And this is an important distinction that has been quite hard to get a grasp of earlier, but thanks to looking at properties and having these simple concepts, we can actually now define the exact difference of a class and a type, which is what the question I posted on LinkedIn was about. So to conclude this, we can then draw the conclusion that both apple and oranges are different types of the fruit class. And hopefully the old Greek guys can rest in peace now. Thank you very much.